This video is about 3D shapes. We're going to focus on finding the volume of cubes and cuboids and their surface area, and then also finding unknown dimensions. So cubes and cuboids are 3D shapes, and they're examples of polyhedra. Now polyhedra is the plural, and one is a polyhedron. And a polyhedron is a three-dimensional shape where all the sides are flat. So here are a selection of shapes. Take a second to see, can you identify which one of these is not a polyhedron and why? So this cylinder is the odd guy out, he's not the polyhedron. And the reason for that, of course, is because although he has a flat top and bottom, he's also got a curved section around the middle. And so the surface isn't flat, so that stops him from being a polyhedron. Still a 3D object, but not a polyhedron. On the other hand, these are all polyhedra. They're all 3D shapes with flat surfaces. And they are two cuboids and a cube. And we're going to look now at finding their volume, and then we'll move on to surface area. So we'll start by finding the volume of this cuboid. And the formula for the volume of a cuboid is length by breadth by h. And of course, notice that a cuboid is a three-dimensional shape, and these are the three dimensions that we're talking about: length and breadth and height. And of course, a dimension is just a measurement. So I have to take 3 measurements to find the volume of this cuboid. So I'm going to measure the length of the cuboid, the breadth of the cuboid, and then the height of the cuboid also. So let's see what these come out as. Well, the breadth, first of all, and being as accurate as I can, is 2.9 centimeters. So I'm going to make a note of that for myself. And then I'm going to measure my length. And in this case, again, as accurately as I can, my length is 5.9 centimeters. Notice how I'm making a note of the units in each case. And now I'll measure the height. So the height of this is, again, as accurately as possible, 1.4 centimeters. So now that I have my 3 dimensions, I can find the volume. So the volume of this cuboid is 2.9 by 5.9 by 1.4, and that comes out as 23.954. And my unit for volume in this case is centimeters cubed. Now you might notice there that in my formula I wrote down length by breadth by h, but when I filled in my values I put in breadth by length by h. It actually doesn't make a difference because the positions of these values in the formula are actually interchangeable. When you multiply a set of values together, the order in which you multiply them doesn't matter. Okay, so I'm going to do the same again now. I've got a different cuboid. I'm going to calculate its volume. What I'm going to do this time is I'm going to give you the measurements for the length, breadth and height, and I want you to then pause the video, calculate volume yourself, and then play again and check if you're correct. Don't forget to include your units. So the dimensions for this cuboid are 5.9, 2.9 and 2.9 centimeters. So pause now and calculate your volume. My calculation should look like this, and my solution is 49.619 centimeters cubed. Now here we have a cube. So a cube again is going to have volume of length by breadth by height. But I wonder, do we actually need to do 3 measurements this time? Have a think about that for a second. Okay, well, actually, I only need to do 1 measurement here because if it's a cube, all its sides, all its edges are the same length. So I'll just take 1 measurement and that'll do me fine. So when I carefully measure my cube, I see that the length of one edge is 2.9 centimeters. So I'm going to make a note of that for myself. Now, like I said, I don't need to do this measurement 3 times. I know it's a cube. I'm actually telling you it's a cube, so I'm going to let you make that assumption. And then I want to calculate its volume. So I could say 2.9 by 2.9 by 2.9. But I wonder, is there a more efficient way of writing that down? Have a think for a second. How else could I write 2.9 by 2.9 by 2.9? Not looking for the answer just yet, just a different way of writing that. Okay, so that could be written as 2.9 I should say, cubed. And so that's where the word for cubing comes from, because when you multiply a thing by itself 3 times, it's like you're finding the volume of a cube. So 2.9, and that is the power of 3 comes out as 24.389 centimeters cubed. Now, thinking back to the formula for volume for a cube, it seems a bit excessive to write down length by breadth by height if I don't actually need to go about writing all of that out in my calculation. So take a second for yourself, and is there a better formula, a more concise, efficient formula that you could write down for the volume of a cube? Take a second to have a think about this, see what you come up with, and then unpause the video. So what I'm going to do is I'm going to call the length of an edge of the cube x. Okay, you could call it L or A or B or whatever you want. I'm going to call it x. And once I've called it x, then I know that I'd have to multiply x by x by x, length by breadth by height, to get the volume. So x by x by x, a nicer way of writing that is x cubed. And this is a nice concise way of writing the formula for the volume of the cube. So here's another cube, and apologies if it's a little bit dark, it's very dark today. Here's another cube, and again I want you to calculate volume. So I'm going to provide you with a side length, and then I want you to pause the video and calculate the volume. And then you can unpause and check if you're right. So this particular cube has an edge length of 2.4 centimeters. I'm going to write that down. So length is 2.4 centimeters. And I know that to get the volume, I just have to cube that. And so when I calculate that, 2.4 cubed, I'm going to get 13.824 centimeters cubed. So this time now we're going to find the surface area of a cuboid. So I've got a cuboid again here, and I want to think about what I mean by the surface area. Well, the surface area, it's not the space taken up overall by the shape, that volume is, it's just the area of each of the faces. And so I first of all need to think, how many faces does a cuboid have? Well, I've got top and bottom, I've got front and back, and I've got the two sides here and here. So that's 6 sides in total. So I need to get the area of those 6 sides. Now, I might be able to speed things up a little bit because some of them are actually the same. So for example, if I think about the top of my cuboid, and I'm going to call that A. And if there's any other face that's the same area, I'll call it A as well. And actually the top and the bottom of my cuboid match, they're the exact same. So I'll call them both A. And then, what about this side here? So this guy here, which was my front a minute ago, I'm going to call it B. It's not the same as the A, so I won't call it A. B, if I turn over my cuboid, there's a B on the opposite side. So I've got a B on that side, and I've got a B on that side. They take up the same area. And then, of course, I've got this end here, and I'm going to call that C. And if I turn over my cuboid, well, I've got a C on this end as well. So actually, I've got 3 pairs of measurements. I've got an A, B, and a C. So when I look at the A face, I can see that its measurements are length and breadth. When I look at the B face, I can see that its measurements are length by height. And when I look at the C face, and apologies now the marker's after bleeding slightly, I can see that its measurements are breadth by height. And I've got 2 of each of those. So let's go back again and just keep track. I've got A, which is length by breadth, but I've got 2 lots of that. And I've got B, which is length by height, but again, I've got 2 lots of that. And so plus, oops, other side, I've got C, which is breadth by height, and I've got 2 lots of that. So my formula for the surface area of a cuboid then is going to be twice the length by the breadth, and twice the length by the height, and twice the breadth by the height. That's my surface area formula, and I'm going to use SA as an abbreviation for that. So let's calculate the surface area of this cuboid. So So the dimensions of this particular cuboid are actually the exact same as the very first one that we saw in the video. So length is 5.9 centimeters, breadth is 2.9, and height is 1.4 centimeters. So when I want to calculate the surface area then, this is how my calculation is going to go. I'm going to say twice 5.9 by 2.9 and twice 5.9 by 1.4 and twice 2.9 by 1.4. And then I'm going to go to my calculator and type that in exactly as I see it. So I'd like you now to pause the video for a second, do that calculation, and then unpause and see if what you got is the same as what I got. So I got 58.86. Now I need to write my units in here. Now I wonder, are they going to be centimeters, centimeters squared, or centimeters cubed? So let's have a think. I'm talking about surface area. So area is always units squared. So this is going to be centimeters squared. Here's the second cuboid we looked at a second time around, and I'm going to give you back the values for its dimensions again, and then I want you to calculate its surface area yourself. So here are the dimensions. So pause the video, do the calculation for surface area, and then see if your answer is the same as mine. And don't forget, as you're doing this, to write down your formula clearly, write down your calculation clearly, and then your solution. Don't just write the solution down. Okay, keep a record of what you're doing along the way. Okay, pause now and go. So my calculation is here, and my solution is 85.26 centimeters cubed. Now, if you're really trying to, push yourself a little bit in terms of your maths, and particularly the different ways of representing your calculations, stop and think and have a look back at that calculation for surface area and think, could I write that in a more condensed way? Okay, this isn't obligatory for everyone, but it's just if you think you can manage this, try and do it. Pause it, and then see if your answer matches mine. So there's a couple of things I noticed here in my calculation for surface area. I've got two lots of 5.9 by 2.9 and another two lots of 5.9 by 2.9. So actually I've got 4 lots of that. And you'll notice, of course, at the end, 2.9 by 2.9 is 2.9 squared. Now, that really isn't necessary when you're doing the calculation for surface area. But again, like I said, it's just about working on your skills for representation of numbers. So now here we are with the cube, and we're going to calculate its surface area. So it's the exact same idea as the cuboid. Again, you could say the surface area of a cube is twice the length by the breadth, and twice the length by the height, and twice the breadth by the height. But as we discussed earlier, actually all the dimensions of the cube are equal. So all the measurements that you'll take will be the same. So I wonder, is there a more condensed way of writing this? So I'm going to call one edge length of the cube x. I want you to have a think about how I might be able to represent my surface area formula for the cube in a much more condensed fashion. Have a think about it for a second, have a mess around with it, see what you come up with. And then pause the video and do that. And once you've done a bit of work on it, unpause and come back and see what I've got. Okay, so my surface area formula is twice length by breadth. Now, if I call length and breadth, both of them x, well, x by x will be x squared. And if I call my length and my height x as well, so all my dimensions are really x because all the measurements are the same, I'm going to have twice x by x again. X by x is x squared. And finally, twice breadth by height. And again, if all the measurements can be called x, then breadth by height is x by x. So that's twice x squared again. So I've got 2 lots of x squared, and then another 2 lots of x squared, and then another 2 lots of x squared. So what's that? Well, that's 6 lots of x squared. So if you've got a cube, a quicker way of finding its surface area is to use this formula. You can still use the formula for the cuboid. So don't forget about that. You will need that for a cuboid. But if you want to get there a little bit more efficiently, 6x squared will get you there. Now, this particular guy, this cuboid, if I just look back, had a side length of 2.9 centimeters. So pause the video for a second and see, can you calculate the surface area of this cube? And then unpause and see if you get the same answer as me. Okay, so my surface area, I'll write my formula down first, equals to 6 times 2.9 squared. And so into the calculator exactly as you see it there. So let's see, I've got 6 bracket 2.9. There's my squared button, equals, I don't think you can see that on my screen. Don't forget to press the SD button. 50.46. And again, units, its area, centimeters squared. Okay, so now we're going to work on finding unknown dimensions. So this is a cuboid, and I'm going to tell you some of its measurements, and I'm going to tell you its volume, and then we're going to find the unknown dimension or the unknown measurement. Okay, so I'm going to tell you that the length, I don't know what it is. I'm going to call it L. And the breadth is 2.9 and the height is 1.4, and the volume this time is 35.728 centimeters cubed. And I want to find that unknown length. So the first thing that I'm going to do is I'm going to use the formula for volume. So the volume formula, I know, is length by breadth by height. So I'm going to fill in what I know and even what I don't know actually. I'm going to call the length L still. I'm going to say length by breadth by height equals to 35.728, which is the known answer for the volume. And then what I'm really trying to do is figure out this L by itself. Now, I had to multiply these guys together to get the volume. So if I want to get length by itself, I'm going to take these values, I'm going to divide them into the volume. So what am I going to get? I'm going to get length equals 35.728 divided by 2.9 by 1.4. Notice here the way that I've written this down. I've got divided and then I've got a bracket around the 2.9 and the 1.4. And so what that says is that each of these values is dividing into 35.728. Everything in the bracket is dividing into this. And then if you pause the video for a second and do your calculation and see if you get the same answer as me. And the length in this case comes out as 8.8 centimeters. Okay, so now here I have a cube and I've calculated that its volume is 175.616 centimeters cubed. And I want to figure out the length of one edge. So how am I going to go about this? I don't have any of the measurements, but okay, let's think back. I had a formula for a cube's volume and it was x cubed. And again, I'm making a note of the formula before I begin to do anything else. So that formula, if I had the numbers to put into it, would spit out the solution for volume. So I'm going to write down x cubed equals 175.616. Now we dealt with this back in the chapter on natural numbers. So I wonder if you can remember, if I know the cube of a number, how can I work out the number itself? So have a think about this for a second. If you need to pause this video and go back and refer to your copy and your notes and what we did with powers, then do that. See, can you figure it out? And then check and see if you get the same solution as me. Okay, so if I want to work out the value of a side of the cube, what I'm going to need to do is get the cubed root of 175.616. And when I do that, I get x is equal to 5.6 centimeters. If I'm not sure if I'm right, I could always take this value and then multiply 5.6 by 5.6 by 5.6 to double check, and I'd find that I would get 175.616. Things to watch out for again, if you have the cube of a number and you want to work out the number, you cube root it. See how that little 3 is tucked into the root symbol? And don't forget to put in your units in your solution. On your calculator, if you're looking for where to cube root, and I'm not sure how clearly you can see this, but you'll see that the button for cube rooting is actually the shift of the square root, and it's just underneath the x cubed button actually. Don't forget to press the SD button with your calculations in order to get them in decimal form.